As we move into section 6 of chapter 10, we're going to talk a little bit about trig ratios. This will be very beneficial for when you get to geometry with Mr. Ledbetter. Alright, we can do this when you come back if you have any questions on it. But let's go down to this triangle down here. Now today, I know I keep going back and forth and back and forth. I want to make sure that I make note you can only use today's lessons, you can only use them on 90-degree triangles, okay, or what we call a right triangle. Now, you've probably seen the buttons on your calculator called sine, cosine, and tangent. Maybe you haven't, maybe you've learned about them, maybe you haven't. You see these buttons here, sine, cosine, and tangent? You might have learned about them, or when you read them, you might think that's sin, cos, and tan. Well, that stands for sine, that stands for cosine, and that stands for tangent. What they do is they help us solve for sides of triangles that are missing. Now, why would we ever use sine, cosine, and tangent if you know a squared plus b squared? Okay? If you can use, this is when you use this when you cannot use, so sometimes you can't use a squared plus b squared equals c squared. Okay, because you might not have two sides. That's when sine, cosine, and tangent come into play. You use sine, cosine, and tangent when you have a degree and a side. Okay, so you use sine, cosine, and tangent when you have a degree and a side. Now you need to understand what sine is. They're all about this word ratios, which means we're going to make fractions. The sine of angle A, which is written sine of A, here's what you do. You take, here's angle A, everybody see it? I like to put a dot on it. You take the opposite leg and you put it over the hypotenuse. Now, cosine. Cosine of A, you take the adjacent leg, and you can see they've labeled them for you, and you put that over the hypotenuse. Tangent of A, you take the opposite across from A, and you put that over the adjacent. I will show you how these are helpful, I promise. Is there an easier way to remember these ratios? I will teach you two ways. The first way is this. SOH is for sine. CAH is for cosine. And TOA is for tangent. Now, how did my teacher help me remember this? She said this phrase. She said, same old horse caught a horse taking oats away. So if you use the first letters of each of those words, you can see how that was helpful for me to remember. Okay? So same old horse is sine opposite hypotenuse. Caught a horse is cosine adjacent hypotenuse. Taking oats away is tangent opposite and adjacent. Mr. Ledbetter is going to teach you this thing called Sohcahtoa. And it's just to remember another way of saying it is about this chief Indian. And he would say Sohcahtoa. Yeah, but I can teach you that little clever story whenever you come back. It's made up, but it helps. Do they apply to all triangles? The answer is no. We're only going to use these with 90-degree triangles, or what we call right triangles. Now, in your calculator, most of you will have a calculator at home that can do sine, cosine, and tangent. Honestly, the one like at the start menu of your computer will. If you have a fancy calculator, though, like this, you need to go to mode, and you need to make sure that you see how degree is highlighted. You need to make sure that you have degree highlighted and not radian. There's a little more to today's lesson, and it's about angle of elevation and angle of depression. So we're going to get our, just kind of get our vocab out of the way. Excuse me. if you want to take a look at this in your book, it actually doesn't happen until page 648, but an angle of elevation is an angle from the horizontal up to a line of sight. So you see the person here looking up at the balloon. This angle is the angle of elevation. You take a horizontal line and how far they're looking up. An angle of depression is an angle from the horizontal down. So see the person in the balloon? Draw a horizontal line. Draw a line pointing down to that other person. This angle that's formed is called the angle of depression. We will use this in today's lesson. You'll learn a lot more about it with Mr. Ledbetter. Let's learn first how to work with the laws of sine, cosine, and tangent. We're going to start very basic. It says, what are the sine of A, the cosine of A, and the tangent of A? Please don't say sin, cos, and tan. Okay, you're going to say sine, cosine, and tangent of the triangle as shown. Well, remember, they're just ratios. We're not going to learn how to deal with them quite yet. Right now, we're just going to learn how to write them. Here's A. They want the sine. Remember that sine is opposite over hypotenuse. I know that because it's Chief Sohcahtoa. Okay? The sine, look at what I'm doing with my finger, please. The sine is the opposite over the hypotenuse. Therefore, the opposite of angle A, look here, the opposite of angle A is 15 over the hypotenuse is 17. Now let's try making the cosine of A. Look where my finger is. The cosine is the adjacent over the hypotenuse. Here's A. The adjacent to A is this line right here, the straight up and down one, 8. Over the hypotenuse is 17. Now we're going to talk about the tangent of A. The tangent, look where my finger is. The tangent is the opposite over the adjacent. So the opposite of A, look here, ready? The opposite of A is 15 over the adjacent is 8. None of these reduced, but if they did reduce, I would reduce them. Write that down. You would reduce if possible. Let's go to the next problem. What's the sine of E? Well, the sine is the opposite of the hypotenuse. Go find E. Here it is. What's opposite of E? 9. What's the hypotenuse? 15. That does reduce. 9 over 15 is 3 over 5. Now let's talk about the cosine of E. Cosine is adjacent over hypotenuse. I know that from Chief Sohcahtoa. And that would be, the adjacent is 12, the hypotenuse is 15. People struggle to find the adjacent. It's simply the one that's touching the angle that's not the hypotenuse. Let's see, 12 over 15, those both reduce by 3. That's 4 over 5. Now the tangent of E is the opposite over the adjacent. Opposite is 9. Adjacent is 12. Reduce that for 3 over 4. So that was a good practice just getting familiar with sine, cosine, and tangent and how to make them. What we're going to do in problem 2 is you're going to learn how to solve for missing sides. Okay. Oh, before we even do that, you just need to have practice putting it in your calculator, okay? Now what's funny, maybe not funny, is before people used to have this really big chart and they would have to like use this chart to figure out all this kind of stuff. I think Mr. Ledbetter will teach it to you, but today we have our nice handy dandy calculators that we don't need to do that anymore. So it says, what's the value of cosine of 55 to the nearest 10,000? Well, first of all, do you guys know what a 10,000th is? Okay, how many decimals would that be? Think about it. It should be 4 decimal places. Alright, so we're just going to get our calculator and we're going to do cosine of 55. So the ratio is 0.5736. when we round. Okay? And what that is that's the ratio. That would be what the fraction would equal. Like up here, 9 over 15. 9 over 15 would be 0.6. This one is 0.5736. Now the got it. Ready? Sine of 80. Let's just get your calculators. Now you should be trying this on whatever calculator you're going to be using, because that will tell me if your calculator is in the proper mode. They want, again, 4 decimals, so 0.9848 for this got it. Now we're going to solve for missing sides. How can you figure this thing out? All right, well, I'm going to go and I'm going to put a dot on the angle that I have. Here it is. That angle is 48 degrees. This is the angle. I'm going to notice that I have the opposite and that I have the hypotenuse. So if I have same old horse, caught a horse, taking oats away, what has the opposite and the hypotenuse? The sine does. So I'm going to do sine of 48 equals the opposite over the hypotenuse, so x over 14. And now I'm going to multiply both sides by 14. And watch what I get in my calculator. Get your calculator. Oh, oops, I don't care what calculator you use. Just do 14 times the sine of 48. The answer is, do they care what we round to? To the nearest tenth. 10.4 and no units, so 10.4. Not too bad, is it? Now, could you have used a squared, b squared, and c squared? No, because you don't have the two sides. Let's write that down to make sure you understand. Can't use a squared plus b squared equals c squared because you only have one side. Now, could you use a squared, b squared, and c squared now? Absolutely. But it's not necessary. To the nearest tenth, what is the value of x? Okay, now I'm going to go and I'm going to find what angle I have, and that's this angle right here. You see it? It is 35. X is the hypotenuse, and you see this number down here? This is the adjacent to that dot. The opposite would have been over here, which I do not have. I have the hypotenuse and the adjacent. So I get Sohcahtoa, or same old horse, caught a horse, taking oats away. I have the hypotenuse and the adjacent, so I'm going to use cosine. Cosine of 35 degrees equals the adjacent 1.575 over the hypotenuse of x. I would cross multiply, okay? Or what happens, let's go ahead and cross multiply. Let's walk through the steps. Multiply both sides by x. So you get x of cosine, x times cosine of 35 equals 1.575. Divide by the cosine of 35 to take it over. And get your calculator. X equals 1.575 divided by cosine of 35. I get x equals 1. They went to the nearest tenth, 1.9. Let's try problem 4. This is how to find a missing angle. Notice that on problem 3, x was in the top, or the numerator. Notice in the got it, x was in the bottom, or the denominator. Now look at problem 4. I'm going to teach you where x is going to be. It says, what is the measure of each angle? Well, let's take a look and find A or C. Just make a choice. I'm going to solve for C first, okay? They're saying, what is the angle? So I'm going to put an x right here. All right? I'm going to separate this because we've got to find angle A too. So we're going to start by finding angle C. I have the opposite and I have the hypotenuse. Since I have the opposite and the hypotenuse, I'm going to use sine. Because see how it's opposite and the hypotenuse. So I do the sine of C equals the opposite 12 over the hypotenuse of 24. Now what you have to do here is you have to use what we call the inverse. By the way, you can make that 1/2 if you want. Watch what I'm going to type in my calculator. I do the inverse of sine and I use a -1 to indicate that, of 12 over 24, and I set that equal to angle C. So I'm going to do, watch what buttons I have to hit. I have to hit second, sine, and then 12 divided by 24, and now I'm going to hit enter. That degree is 30. So I'm going to say 30 degrees equals angle C. Now you might say, how do you find angle A? Well, I should know, and so should you. You should know that a triangle equals 180 degrees. So if I add angle B, angle C, and angle A, I should get 180. Let's do that. Angle A plus angle B plus angle C should equal 180. So angle A is the one that's missing. Angle B is 90. Angle C I just found to be 30. Solve for angle A by subtracting. I'll do 180 minus 90 minus 30, and you should get 60 degrees. Now what if you didn't want to do it that way? Could you do something else? Yes. You could do the inverse of the cosine for A of 12 over 24. Notice how we would have got 60 for that as well. And why would I have done that? Because if I do A, 12 would have been the adjacent, and that means I would have had to use cosine. In the got it, we need to be able to solve again for an angle. I'm going to do that in another video.